Hi. After watching this presentation, you should be able to explain the behavior of short and open faults and how we can detect them. Let's start with the floating input. If there are internal pull-up resistors, as we have previously seen in the case of the TMS and TDI tap inputs, we know that the boundary scan cell associated with a floating input will always capture a logic 1. If pull-up resistors do not exist, the type of technology used for implementing the input stages may also determine that we continue to capture a 1 when the input is floating. This is normally what happens in TTL bipolar logic, and likewise in the case of the boundary scan devices that we will be considering as examples. But it may also happen that a floating input will end up at an intermediate voltage level between ground and the power supply. And in that case, we cannot predict if a 1 or a 0 will be captured by the associated boundary scan cells. In a case like that, we may have to repeat the test several times, because the probability that a random value coincides with the expected value in a sequence of test experiments will fall exponentially as the number of test experiments grows. And what about the case of shorted outputs? Well, if the output impedance is lower when the output is at 0, then 0 will be the dominant logic value. And of course, vice versa. This is because the rate at which the voltage level falls in the outputs at logic 1 as the current increases is higher than the rate at which it rises in the outputs at logic 0. But keep in mind that this also depends on the number of outputs that are shorted together, because several outputs at 1 may give out enough current to override a single output at 0. However, the important thing is that there is a dominant logic level, and it doesn't matter if it is 0 or 1, because in that case we expect to find at least one error in the logic values that are captured at the boundary scan inputs connected to the shorted pins. If there is no dominant logic level, then we may have to repeat the test several times, as we have seen in the case of floating inputs. So let's look at specific examples, starting with a short fault. In the case of X2, you should start by looking at the logic function of IC1, which is a simple dual 2 to 4 multiplexer. This is not a boundary scan device. Check up its function table by going to Canvas or Googling the reference code 74LS139 and find out what logic values should be driven to the boundary scan outputs of IC3 so that we get opposite logic values in the two shorted pins. And then find out the expected test response at the boundary scan inputs of IC4. To conclude, let's look at the case of open fault X1. In this case, we can assume that an inverter with a floating input will take it as a logic 1, because this is TTL bipolar technology. So we can only detect this fault if we drive a 0 from the corresponding output of IC1. And again, we have to find out what logic values shall be driven to the boundary scan outputs of IC3 and what will be the expected responses at the boundary scan inputs of IC4. And that is all. Thanks for your attention.